Okay, getting the week 4 video out a little late, basically because Monday was an off day, and so I didn't do this on Monday. Today, basically the what we're doing today is going to be a combination of chapters 5 and 6, which is on something called the Dirac delta function, which you should remember from differential equations, and the Fourier transform. Now, we're going to spend most of this week just discussing what the Fourier transform is and its properties. Now, it might seem a little bit confusing and abstract and esoteric. We're gonna see application of the Fourier transform to partial differential equations this week, but we'll really start looking at that more next week. You might remember from your differential equations class, there's this thing called the Laplace transform, and you could use the Laplace transform to solve differential equations. Very similar thing is going to be happening with the Fourier transform. We're going to use it in a way very similar to how we used the Laplace transform. We're going to use the Fourier transform to solve partial differential equations. So just kind of go with me for a little bit. I'll mention some properties of the Fourier transform and why people care about it as we go along in the videos. We'll see some applications to differential equations later in this class, and then next week we'll really see some applications using the Fourier transform to solve the diffusion equation and other things as well. And it's something that in one form or another is basically going to be with us for the rest of the class.